Part D. Given that f of 1 is equal to 3, write an expression for f of x, that involves an integral. And since it involves an integral, we can assume that it's going to involve f prime somehow, especially since they've given us so much information about f prime, including its graph and the area under or above the curve at different intervals. And then they want us to find f of 4 and f of negative 2. So let's think about how we can connect f prime, an integral, and f of x. Well, if we took the integral from a to b of f prime of x dx, what is this going to be equal to? Well, this is going to be equal to the antiderivative of f prime of x, which is f of x, and you're going to evaluate that at b and a and subtract the difference. So this is going to be f of b minus f of a. This is straight out of the fundamental theorem of calculus. All right, so this is interesting. Well, what instead of having a b, what if we had an x there? And if we're going to put an x as one of our bounds of integration, well, we'll use a different variable for our integration here. So let me write it this way. So if I had the integral from a to x of f prime of u du, well, what is this going to be equal to? Well, this is going to be, by the same logic, the antiderivative of this evaluated at x, so f of x minus f of a, minus f of a. Or if we wanted to solve for f of x, we could add f of a to both sides, and we would get f of x is equal to the integral from a to x of f prime of u du. And once again, why did I pick u? Well, I just needed some letter other than x, since I already used x as one of my bounds of integration. And I'm adding f of a to both sides. I swap the sides too. So f of x is going to be equal to this plus f of a, plus f of a. So this is a general form if a is a lower bound, but they gave us some information. They said that f of 1 is equal to 3. So if we choose a to be equal to 1, if we say this is 1 right over here, this is 1, then we know that this is going to be equal to 3. So we can write f of x is equal to the integral. I'm using 1 as my a, since I know what f of 1 is, from 1 to x of f prime of u du plus f of 1. They told us what that is. That is going to be equal to 3. So this is the first part right here. We just did it. That is the first part of the problem. Now let's try to find f of 4 and f of negative 2. All right. F of 4, well, wherever we see next, we substitute a 4 there. It's going to be integral from 1 to 4 of f prime of u du plus 3. So what is going to be the integral from 1 to 4 of f prime of u du? So let's look up here. So the integral from 1 to 4 of f prime, that's that curve right over here. Well, that's going to give this area, but it's going to be the negative of the area, because if you just take the integral, it's the area that you could view above the x-axis and below, or if we're thinking in terms of view, above the u-axis and below the function. But this is the other way around. The function is below the horizontal axis here. So this area, which they told us in the problem, the area bounded by the x-axis in the graph of f prime over the interval 1, 4 is 12. So this area over here is 12, but the integral is going to be a negative, because once again, our function is below the x-axis. So this integral, this right over here, is going to be a negative 12. This is negative 12. So negative 12 plus 3 is negative 9. All right. Now let's evaluate f of negative 2. F of negative 2 is equal to the integral from 1 to negative 2 of f prime of u du plus 3. Well, it kind of feels a little strange to have the upper bound being lower than the lower bound, so we can swap the bounds and then add a negative out here. So this is going to be equal to the negative of, if we swap the bounds here, so from negative 2 to 1, f prime of u du plus 3. So what's the integral from negative 2 to 1? Well, they give us that. From negative 2 to 1, they told us that this area over here is 9, but But once again, because it's below the horizontal axis and above the curve, we would say that the integral will evaluate to be negative 9. So the area is 9, but once again, the curve is below the x-axis. So the integral would give us negative 9. So this would evaluate to negative 9. So you take the negative of negative 9, which is positive 9, plus 3, which is equal to, so 9 plus 3 is equal to 12. And we're done.